Okay. Hello. Good afternoon, everyone. Hello. Hello. Good afternoon, everyone. So, hello. Good afternoon, everyone. Today I'm Navya, and I'll be continuing the topic serverless computing and AWS Lambda. First, let's see what is serverless computing. We'll understand serverless computing by understanding its four main core characteristics. First is no server management. No server management essentially doesn't mean that there are no servers. It just means that we are outsourcing the managing part to a third-party service. So basically, in traditional sense, companies used to manage their data on physical servers and also maintain the service. Nowadays, they prefer to deploy their code on a server which is maintained by a third-party service. Second part is event-driven execution. All these functions are triggered by a certain event, which can be an HTTP event or like a file upload, database change, etc. Third is that it is stateless function. So once an event is triggered, a connection is established. Then a process is completed. After the termination of the process, no data is stored inside the web. So the storage is empty once the state or the function is completed. Next, it is fine-grained billing. We only pay for the services we use. So basically, we only pay for the server uptime. And all the times that the service is in the downtime, we don't pay for that. This way, it saves a lot of money because we don't actually invest into the management part of the service. Next, we'll talk about the execution. Suppose we have a user who triggers an event. This triggers the serverless function. Once the serverless function is triggered, a process or a function is executed. The data or the picture or anything which is obtained after the function can be either stored into a database, a file storage system, or can be sent back to the user through an API or an email, anything. So now let us discuss about the advantages of serverless. First one, you don't have to manage the server. So you're not investing on like the server management. Second, it is auto scale. So when you're trying to scale from like 50 customers to 1,000 customers, you would naturally want to increase your number of servers and also its maintenance. That is a bit hard. But now with serverless computing, the third party company only does it for you. So you don't have to worry about that. Third one is cost efficiency. As we discussed, we only pay for the uptime. Hence, it saves a lot of money. Fourth one is faster development and deployment. Nowadays, companies don't have to worry about the infrastructure. They only worry about the code. Hence, they're able to generate more code and more functions in lesser number of time. And the last one is tight integration with cloud services. Like once your data is received after the process, you can either choose to upload it on a database, file storage system, or like the authentication part. Everything can be handled like to and fro motion, like you can integrate with other services. So hence this way you have best of all the worlds. Next, we'll talk about some of the challenges and considerations. As the server is not always on uptime, when you trigger the function for the first time, your runtime might be a bit more. But subsequently, it will start to reduce and become normal. Second one is limited execution time. For example, AWS Lambda gives you a 15-minute time frame. If your function exceeds that, it will automatically shut down. But a simple like an email bot or a HTTP request server usually takes only milliseconds to process this information. So that is not much of a big of a problem. And the third one is debugging and monitoring complexity. Whatever code you push onto the cloud is usually in the form of microservices or functions. So each function is usually, triggered by an event-driven function. So when a bug is occurred or whenever you have an error, it is a bit difficult to find from where it originated. So you usually use logs and other systems which are provided by AWS so as to overcome this challenge. It is not critical, but it can be a little bit tricky. So in this web services department or domain, we have major players like Google, which provides GCP, Microsoft, which provides Azure, and Amazon, which provides AWS. Today, we'll talk about AWS Lambda, which is their serverless computing component. First of all, why AWS? So all the advantages of serverless computing we talked about previously, like auto-scaling, no server management, pay-per-use, everything is in AWS Lambda. And one more thing which I would like to stress on is the security part. Basically, AWS provides you two things. One is a root user, which is like the main person in the organization, and other IAM users, which are like identity and access management users, which only these people have access to the code of a certain organization. So you basically don't have any stress about data leaks and data threat and etc. So usually serverless computing works with two mechanisms. First is a FaaS and a BaaS. BaaS is actually Backend-as-a-Service, wherein you give your front end and upload or like deploy your code on the database which is available on the cloud. So basically it doesn't mean that you're actually maintaining the database, but basically you're just performing thread operations with the database. Second one is FaaS, or function as a service. Here we use event-driven functions so as to trigger our service or like the Lambda function, which can be of certain types. For example, AWS integrates with the fellow tools like Amazon S3, which is their file storage system. So when you want to upload a file or delete a file, you can trigger the Lambda handler function. Or you can use the HTTP API backends or schedule jobs, wherein you can trigger the function like in certain intervals of time. So you use CloudWatch for this. Next, the last one is DynamoDB, which is their in-house database. So any CRUD operations with the database can lead to a trigger. Now let us understand some use cases of AWS Lambda. First one is stateless application development. I'm sure we've all gone into McDonald's and clicked on the Coca-Cola machine, which loads an animation and fills up your cup. They use AWS Lambda bundle. So when you click on the button, say like fill it up or something, an event is triggered and the animation is loaded. Once the animation is finished, all the data of where the trigger was from whom, is all removed. This way, they were able to serve more number of customers in less number of time and also pay less for the web services, as they're not storing any information. Second one is batch processing. Liberty Mutual is actually a law firm which works in different countries. So they were finding it difficult to find a model for their billing processes. So they decided that they will batch process all their documents at the end of the month and then generate the bill. This way they used AWS Lambda, wherein they didn't have to worry about the server management for the rest of the month and only paid for the services for the time of the month they would batch process their documents. Third one is real-time data analytics. This was used by Genentech, which is a biofirm, which basically generates the genome of viruses. What they did was, before, they used to take 2 weeks to generate just the structure of a virus. With AWS, every information they would receive, they would put it into the function and generate results. This way, they were able to generate the whole genome structure within 2 or 3 hours. Next one is business process automation. Taco Bell, as you all know, they have QR code system for like the menu ordering system. So once you order any food through the QR code, an event is triggered, and the data is stored in the database or like the cloud, until and unless the customer receives his food. Once the customer receives his or her food, then the data from the database or the cloud is removed. Hence, they were able to serve more customers in an orderly manner without spending much on it. Now let us see how is it DevOps and CI/CD friendly. As we know, GitHub Actions are basically used for deploying the code to our web services. AWS also has its own pipeline, which is called as AWS Code Pipeline. So basically, whenever we upload a Lambda handler function onto the web, it directly deploys it. And it gives us 2 major advantages or services. One is green, blue, and canvas. Green, blue is basically that if you have any code error or like a bug in the present deployment, you can version or roll back to the previous deployment. And the second one is canopy. So it allows you to test your changes with first a set of people, like say 10% of your customers. If it's fine, if it's working proper, then you can roll out the changes to the other 90%. So why does it matter? This way, we reduce the human intervention in the code pipeline, and hence there are less technical errors, which helps in efficiency. Finally, we'll see what is the general workflow of AWS. This is, let us assume that we have a function which resizes images. So first, the user uploads the image to SP. Then the SP event triggers a Lambda function. The function resizes the image. The resized image can be stored into the database, and also a notification can be sent to the user that the image has been resized through an email. So yeah, this was all about serverless computing and AWS Lambda. Thank you for listening, and we are open for questions. Thank you.